Okay guys, have a look at negative and fractional indices now. Here are the index laws, or the power laws as you might know them. Basically, from what I've seen from your guys' Churchill papers, you guys are totally okay with these first three. Bear in mind that of course you don't get these on your formula sheet, so you do have to know these, and you guys are totally fine with the first three. The thing that I've spotted which has caught a few of you out on your Churchill papers recently is these bottom three, the negative and the fractional indices, as well as this one in brackets. So it's a few examples of these three power laws that I want to look at now, and make sure that you've got these all written down, you've got the notes, and that you do know them. Write them on post-it notes, stick them on your bathroom mirror, stick them on your bedroom ceiling, whatever you need to do to learn these. Get them learned. Okay, so we'll have a look at this one first. This power law, where we've got a variable raised to a power, and then that in brackets raised to another power. There's a classic case that has caught us out a few times. I want to have a look at it, but we'll start with this one: 3 squared in brackets and then that all squared. So we would literally follow the power rule. As you can see, that becomes 3 squared times 2. We multiply by the term outside the bracket, which is 3 to the power of 4. Okay. This one, it works with algebra 2, so this one becomes x cubed times by 4, the cube is times by 4, so that becomes x to the power of 12. This next one, you simply need to multiply each variable's power by that 4, okay? So this has caught a few people out before. This one would be x cubed, and then the cubed is times by 4, y squared, and the squared is times by 4. So this one is x to the power of 12, y to the power of 8. So you can see it's literally just multiplying each index of each variable by the 4, by the term outside, the power outside the bracket. The one that keeps catching a few people out on the Churchill papers is this one. People get into their mind that they are just multiplying the powers, and they end up just doing 2 times 3 for the coefficient, but that doesn't work. We'll have a look at why. If we write this number 2, that's really 2 to the power of 1, isn't it? And the same thing as the above example, we're just going to multiply the power outside the bracket by every one of the powers inside the bracket. So this 2 to the power of 1, the 1 needs to be times by 3. And then in x squared, the square, the 2 needs to be times by 3. So that is actually 2 cubed, which is 8, x to the power of 6. And what's caught a few people out before is that they get into their mind that they are multiplying the powers, which is absolutely true, but some people end up doing the 2 times 3 and would write the coefficient of 6, x to the power of 6, and that would of course be wrong. We're multiplying the powers, and the powers of the power of the coefficient 2, the power is 1, isn't it? Okay, so it's that 1 times 3, and that's why we end up having to cube the 2. Okay. Have a look at another one now. This is the negative power law. A to the minus n is equal to 1 divided by a to the n. So if you see a negative sign in front of a power, don't panic. Just think, that just means that I need to write it as 1 over a to the n. Okay. So 2 to the power of minus 3 is the same thing as 1 over 2 to the power of 3, or an eighth. So simply just remove the negative in front of the power and just write it as 1 over that. Okay, works for algebra 2, so x to the power of minus 5 is the same as 1 over x to the power of 5. Make that 5 look a bit better. Okay, now what if you've got a coefficient in front of the x which has got a negative power? Let's have a look at how this works. Well, this one is actually 2 over x cubed. So you can see that what I've done with this is really I've separated out the 2 and the x to the power of minus 3. The x to the power of minus 3 goes on the denominator, goes on the bottom as x cubed, but the 2 stays at the top. I guess another way of thinking about this would be to say that 2x cubed is the same thing as 2 times x to the minus 3, which would be 2 times 1 over x cubed, which is the same thing as 2 over x cubed. So if you want to see where that comes from, hopefully that gets you there. Similarly so, just to extend it a bit further with this example below, using the same approach, this one becomes 3x squared over y cubed. Okay, just to finish off then, there's this one which is the fractional indice, the fractional power. Basically, I think you guys are okay with knowing that 9 to the power of a half is exactly the same thing as the square root of 9. But what I want you to recognise that the numerator, the m in the fraction, if you like, in the power law, is actually the power of 9. So that's really 9 to the power of 1, or just 9. So that's where that comes from. Obviously the square root of 9 is 3. 3 times 3, or 3 squared is 9, so the square root of 9 is 3. Let's have a look at this example below now, which is x to the power of 2/3. Well, follow the power law in writing out. This becomes x squared, all cube rooted. This one, 2 to the power of 4/3, just becomes 2 to the power of 4 cube rooted. Or maybe you'd like to actually do that 2 to the power of 4, which is 16. So that would be the cube root of 16. And then to finish off, the really tricky one, the one that really can catch a few people out, what I've got now is a negative power and the fractional power. So let's have a look and see how this works. To start with, remember that just think about the negative power first, so, and what the negative does. So this becomes 3 over x to the power of 2/3. Remember that the negative just means that you have to put that on the denominator of the fraction. Okay, now we've got that far, we can then worry about the fractional part of it. So this is 3 over x squared all cube rooted. Now that's a particularly nasty one, but I can't promise something like that wouldn't come up on your paper. So really it was just the technique with this last one was splitting the problem into two, considering the negative part first, and that just simply moves that x to the denominator of the fraction, and then we worried about the fractional part. So don't worry about having to do it all in once. You can break it down into steps. Do the negative bit first, and then do the fractional part of the power. Okay guys, that's everything that you need to know about the power laws. Have a watch of this video. Please make sure that you forward this video on. Can you email the links around the class so that everybody in the class gets a chance to watch this video? Thanks, and I hope you found it useful, and I hope I can get back to school soon to carry on helping you with your maths. Alright, take care guys, see ya.